So Junling, thank you for that really thoughtful, thorough sort of overview of all the things behind ChatGPT. Kasaba Top, who's in our stream, asks a question about the encoder and that wasn't used even in the training phase. Can you expand a little on, or do you know why OpenAI didn't use the encoder?
Yes, so encoder is useful for transform the input to create an internal representation embedding, then send that to the decoder to generate. But to train the data, encoder itself does not give you feedback on whether the data is correct or not. So we have to generate the output to go all the way back to the input. In order to get a feedback from the data, so decoder is the most essential part. So by removing encoder, the training can be faster and then take advantage of all the decoder side. And that's why OpenAI did not use decoder. In fact, Google also moved toward the decoder only architecture. They actually moved away from original BERT. BERT is the encoder, pure encoder architecture, but now Palm in Google, it's all using just decoder. So this is the trend that people only use decoder.
Okay, thank you. You talked about data sets. ChatGPT was trained on web text too, books, Common Crawl, Wikipedia. A couple things. What is Common Crawl? I hadn't heard of that before. And are these data sets publicly available? Are they available in multiple languages? Could you talk about that some?
Yeah, so all of these data sets are public available. Common Crawl, you can go to commoncrawl.org. It's a public data set anyone can use, and they also ask people to donate. The most data set, all of them are in English, but because the web page has multilingual, like Wikipedia has probably other languages, it can contain other languages, but majority is in English.
Oh, so is that true then Chat GPT and the earlier one we're struggling with an easier way to say that name like Flippy 2. So Chat GPT is English only. There isn't a Spanish version or a French version because I know it does translations.
Yes. So the way it translations is still through the web page. We use web text. So in the web text, if you have a document, say if you tag every English word and it has a parenthesis, a French word, then it automatically learns they're associated. Those words are associated together, and then you can also give instruction inside the original documents indicate that these two are corresponding to each other. For example, in the Canadian website, they have both French and English. And in some other website, they have English and other language. So they learned automatically through the same route how different languages are corresponding to each other. But there's no specific language for them to learn. In general, they just trained all type of documents on the internet, however many language are there. So that's their, so it's English main focus, but somehow they learned other language. This actually is described in described in GPT-2 paper. So why it suddenly was able to detect the multiple language in many English corpus. Yeah.
I'm fascinated by the word embedding that you talk about, the hidden space, and the dense representation. Can you describe that a little bit more? Like, have these dense representations of words been around for a long time? I take it that there's not one, there's only one for English because there isn't one like one for French or Spanish. Is that the case?
It's one for any language, for any word. So whether it's English, Spanish, Chinese, Japanese, every character, a main word can be mapped to a vector. So that is the theme. That's how computer can recognize and then process the word we speak in human language. Computer only knows numbers, 0, 1, and maybe floating numbers. That's what a computer knows. So we converted the word into a vector of numbers. Now, when we say dense vector, this vector is very small and it doesn't have many zeros. It most contains non-zero numbers, so it's dense. the size of the vector, it's really arbitrary. Actually, we can pick the size. Original BERT is 256, then people expanded to 512. Now we can do twice amount. It's really our computing power. So we decide how large this vector is. When we say hidden space, essentially is meaning when we represent the word in the dense format, small vector, somehow we can discover the relationship, but it's not randomly discovered. We discover that by use pre-training, by going train the network, train this neural network through the many web texts to understand how the first word predict next word, first sentence predict next sentence. After that, those hidden space, those word embedding, then can tell us relationship between words.
Fascinating. Centaur L asks, what are the options if one wants to train ChatGPT on my own training data instead of the data that's available on the web?
Very good question. Right now, what the option they offer is you can upload your data set to OpenAI, and then they will train for you on their web, on their infrastructure. But they haven't open sourced the ChatGPT, the last GPT-3 model. So we don't know what the model look like. We don't have the parameters. That's still a secret of OpenAI. If you need to build your own similar open source ChatGPT, you probably need to download from Hugging Face, get some current like GPT-2 model or OPT model from Facebook, or T5 model from Google. So you can get some open source model, then follow the instruct GPT methodology, do some reinforcement learning on top of that. Then you can create something similar to ChatGPT.
Right. Doesn't sound easy, but sounds possible.
Yeah.
Do you have from your talk some good online resources if someone wants to learn more about the concepts? Roper is asking us this question. Online resources for the things that you talked about in your presentation.
I would recommend read the 3GPT paper, the one from 2018, the original GPT paper. Those are listed in my talk. The GPT-2, GPT-3, and then last paper is instructed GPT. In terms of explaining, I think it's so new. ChatGPT just came out end of November 30. So it's only like 2 months. And I don't know if anyone have written materials. Maybe I'm thinking about writing the instruction material for that. Maybe there's some online talks. I also have another talk on a much deeper about ChatGPT. So I think that's all we have. I would just encourage you to watch the video I just gave and on the major timeline, the major papers I mentioned. So I think that's the best way to go about learning about this.
Okay, thank you. I'm going to ask about Instruct GPT. You mentioned that GPT-3 generates one word at a time, like ChatGPT, but it was difficult to use, and that you said Instruct GPT made it significantly better. Can you explain what Instruct GPT did to improve GPT-3?
So GPT generate one word at a time. Instruct GPT also is the same. Instruct GPT is still the GPT-3 model, but add on top of that with reinforcement learning feedback to make the model better. So it's for every decoder model, every GPT model, they only generate one token at a time. That's including ChatGPT. What instructed GPT does is what previous speaker Carson also mentioned, and I mentioned at the end, is a reinforcement learning methodology to instruct the model to behave better. So the way they do through 3 steps. The first step is supervised learning by human to write a question answer, almost like a human act like a ChatGPT, write some question and then generate some answers. So this can be a supervised training material to update the GPT-3 model. After that, then they train a reward model. The second step is reward model, where you let the GPT generate two different answers, and the human label which one is better. The better one get higher reward. And the last step is a reinforcement learning model, where the reinforcement learning essentially is the GPT-3 model itself. The input is the sequence of words. That's a state. Output is action. Action is one of the words you should choose. Essentially, when we have 30,000 action, is the total. If the total number of vocabulary is 30,000, so that's how they choose the best action. And so this 3-step is instruct GPT.
Okay. Are there any sort of innovations in algorithms or machine learning that you see in ChatGPT-3 that you find most impressive? What has OpenAI done that's most impressed you?
I think the major innovation from OpenAI itself is the reinforcement learning. That's originally invented in OpenAI. A year before that, they used reinforcement learning to improve book summarization. So when book summary used to be difficult, the summary is not accurate when the document is very long. So they introduced this human RL, reinforcement learning, HF, human feedback. With this methodology, they see a dramatic improvement. So the same author worked on GPT-3 and wrote the paper Instruct GPT, and that's a breakthrough. Now, before that, the major technology is Transformer. We know Transformer was invented in Google, but GPT also is the first one come use a large online document to do pre-training. So this is the innovation, the pre-training part. People understand the pre-training, but the first time we use a very large online document to do pre-training. And the essential power comes from the model size. So GPT-2 is only 1.5 billion, GPT-3 is 175 billion. So it's 100 times more than the previous model. Secondly, the data also 100 times larger than previous data. So the main power comes from the data size and the model size.
Are they continuously feeding it new data, or is it now reached a static level?
For each model, you train only once and use that later by adding more prompt, other information. If they want to train GPT-4, they probably collect additional more data. There are more text data they can collect. There are even more books, more manuals. There are many more data you can add, but they trained once. It's not like they train every day. They cannot afford that.
Okay. We have another question on the chat. So we're talking about the special power between ChatGPT, and one is the RLHF, the human factor in machine learning. The other one is the PPO, which was the, oh gosh, can you remember that algorithm, what that stood for?
So
proximal policy optimization. Yeah, is that an innovation that's in ChatGPT-3, or is that something that's been around in AI?
Yeah, PPO was invented in OpenAI too back in 2017. So PPO is also a unique technology for doing reinforcement learning, and the author published through when he was at OpenAI. So it's a special way to update the policy network that I mentioned with a reward that's bounded by certain range. So that's proximal. The reason is you don't want the reward to be too high or too low to disrupt the current learning. So that's the essential idea of PPO. But they do have mathematical to prove, to show that what kind of bound it actually should set. And that's the PPO idea. And then they gave a formula how you should update your reward, your policy based on the reward.
All right. Well, Junling, thank you so much, and thank everyone else who's joined us. And I'll turn this over to Peter to wrap us up and take us home.
Thank you.
All right. Well, thank you, Tammy, for being such a great moderator, and Junling for a good last session. And certainly want to thank all the speakers. This is all like volunteer Saturday morning stuff where everybody has other things to do on Saturday. So let me take over the screen, and I'm going to tell you in a minute a little bit about the format. There were a bunch of questions that that came up.